Hi, this is Hilal. In this video on Mathematical Economics series, we will try to solve a problem on income determination multipliers. Okay, the question is like this. Given a three-sector income determination model, we are being given three-sector income determination model, that is Y, that's output is equal to consumption expenditure plus investment expenditure plus government sector expenditure. Disposable income is given as Y minus T, that is when we subtract the tax from the income we get disposable income, and the value of C naught, I naught, G naught and T naught, which are the autonomous variables here, they are all greater than 0. And consumption function is given by that C is equal to C naught plus by subscript D naught, that is autonomous consumption plus this B is the marginal propensity to consume and YD is the disposable income. And tax is given by the relationship, that is T naught plus TY, where T naught is the autonomous tax and this T is the marginal tax rate on income. Okay, and this B MPC is MPC lies between 0 and 1. Okay, and the marginal tax that is marginal tax rate marginal tax rate lies between 0 and 1. Okay, we have to find the government multiplier, that is government expenditure multiplier, autonomous tax multiplier and tax rate multipliers. Okay, so let's see how to solve this, and we will also determine the magnitude and the direction of a 1 unit change in the government spending. Okay, and this autonomous tax multiplier means we have to see the impact on the lump sum taxation. Okay, and this tax multiplier, that is we have to see the relation with respect to marginal tax rate. Okay, so how do we solve this, or how do we find the different multipliers? First we will solve for the equilibrium level of income. Okay, for equilibrium level of income we know our Y is equal to C plus I plus G. Okay, this is our equilibrium model. Okay, income model, where output is equal to consumption expenditure plus investment expenditure plus government expenditure. Okay, and we are being given the values of uh, consumption is given by C naught plus by subscript D. Okay, uh, plus we have investment is autonomous here, so we have I is equal to I naught, so I will write I naught here, plus this G is autonomous, so I will write here G naught. Okay, or we can write it like this: C naught uh, this is our consumption function, so I will write C naught plus B. Now yd is equal to y minus t, so I will write in place of y subscript d, I will write y minus t plus I naught plus G naught. Okay, and solving further we have C naught plus B. Okay, then we have y, and t is equal to t naught plus ty. So in place of t, let me draw this long bracket here, so in place of t I will write t naught plus ty. Okay, and we have the investment and government expenditure, that means y is equal to C naught plus this will become by, so I will write here by. Then we have minus b t naught, then we have minus b ty, that is b ty plus I naught plus G naught. Okay, now what will we do? We will just transpose the y values. Okay, we will try to transpose the y values on LHS. That means we take these values on LHS, so we have y minus by, and this will become plus when transposing it, this will become b ty is equal to C naught. Okay, we have minus this term b t naught plus I naught plus G naught. Okay, if we take y common, we are left with 1 minus b plus bt is equal to c naught minus b t naught plus I naught plus g naught, or y is equal to, okay, y is equal to, if we transpose this term on RHS, so this will become c naught minus b t naught plus I naught plus g naught, and this will get multiplied. So I will write here 1 upon 1 minus b plus b t. Okay, so we got the equilibrium level of income as a function of other variables. Okay, now we are in a position to find the government expenditure multiplier. Okay, so what is actually the government expenditure multiplier? We have to see the impact of change in the government expenditure, okay, on equilibrium level of income. When we are talking about change, that means we have to take the partial derivative of this equation with respect to g naught. Okay, so for first, that is government expenditure multiplier can be uh, constructed by, that is, taking partial derivative of our equilibrium income with respect to government expenditure, okay, g naught. That means differentiating this equation with respect to g naught. Okay, now if here we can see clearly the how can I try to make it more clear to you? If I just rearrange this, so I can write it like this: c naught upon this 1 minus b plus bt is divided to each of the terms. So we have 1 minus b plus bt. Okay, then we have minus b t naught divided by 1 minus b plus bt plus we have I naught upon 1 minus b plus bt. I am just trying to make you clear how it is. Plus we have g naught, that means 1 minus b plus bt. Okay, so this is our equilibrium level of income. Now if we differentiate this equation with respect to g naught, that means we will try to find the derivative of g naught. Okay, and we are taking the partial derivative here. Here you can see in the first term no g is involved, since we are partially differentiating with respect to g naught, so the derivative of first term will be 0. Since in the second term there is no g involved, so its derivative will be also 0. In third term there is no g naught involved, so the derivative will be 0. In the fourth term we have g naught, the derivative of g naught will be 1. Okay, so that means we have 1 upon 1 minus b plus bt. Okay, this will be our government expenditure multiplier. Okay, and what does this tell us? Here we can also comprehend, since this b since this b is less than greater than 0 but less than 1. Okay, when this term lies between 0 and 1, okay, and this term also lies between 0 and 1, then if we give any values with the given constraints, this term will be greater than 0. That means this term will be greater than 0. Why? B lies between 0 and 1. Okay, if t also lies between 0 and 1. Okay, 1 divided by anything 1 minus this term and this term, it will become positive. You can check it yourself also. This whole term will become greater than 0. Okay, and what does this tell us? What does this then tell us? It tells us if 1 unit, I will write here 1 unit, 1 unit increase in uh, government spending. Okay, government spending, I will write here government spending will increase equilibrium level of income income by 1 upon 1 minus b plus b t naught, okay, units. So if there is 1 unit increase in government spending, uh, equilibrium level of income will increase by that very units, okay, which is our multiplier, government expenditure multiplier. Also, let us come to the next autonomous tax multiplier, okay. Autonomous tax multiplier means we have to differentiate, take derivative of this equilibrium level of income equation which we formed with respect to autonomous tax, okay. And we are not we are not taking this t in consideration, okay. We are just differentiating with respect to autonomous tax multiplier. That means we need to take dy upon d t naught. That means we are differentiating the given equation with respect to t naught, that is autonomous tax, that is lump sum tax, okay. And what will be the derivative here? Since no t naught is involved in first term, in third term, in fourth term, only in the second term we have t naught, okay. Then what is the derivative of t naught? It is 1, so we are left with minus b upon 1 minus b plus bt, okay. This will be our autonomous tax multiplier, and here you can see it is less than 0 because of this because of this sign. And what does this tell us? It simply tells us 1 unit increase in autonomous tax, that is, I will write t naught, will decrease, there is a negative relationship, okay, because we had the negative sign here, will decrease equilibrium level of income by 1 upon this. Actually we have minus b, let me write it clear, will decrease by b upon 1 minus b plus bt units, okay. So we have here the negative relationship between change in autonomous tax and change in the income, okay, because of this very negative relationship. Now we are done with the first multiplier, second, and now we need to find the tax rate multiplier, okay. We need to find take the derivative with respect to tax rate multiplier. For that, let me rub these two because it will take time, rather it will take space. So if I write this y which we calculated here, y is equal to c naught plus, actually it is minus b t naught minus b t naught plus I naught plus g naught. I can write this like this. I will whole divided by 1 minus b plus bt, okay. Now we need to find the tax rate multiplier, and here you can see the tax rate multiplier. That means we have to differentiate this income model with respect to t, that is this small cap t. And you can see in the numerator we have no small t, the small t is only in the denominator. Then how do we solve this? So it's very easy, we can use the quotient rule here, okay. So what is quotient rule? Quotient rule is simply, if we have two equations, let us say fx upon gx, okay, we have two equations. How do we find, how do we let us say y, anything phi is equal to this, okay. Now how do we use the quotient rule? How do we use the quotient rule? First we write this gx as it is, so let us say we have d phi upon dx. If we want to use quotient rule, how do we do this? We write the numerator denominator as it is and take the derivative of numerator, that is f dash x. Then we write minus and we write this numerator and then take the derivative of denominator, okay, gx, and we divide it by gx whole square. This is the quotient rule, okay. So that means we need to use the quotient rule here. So in place of fx we have this thing, in place of gx we have this thing, and we can use this very method, okay. So that means what will happen to our equilibrium income when the tax rate changes, that is d small t, okay. That means we need to differentiate with respect to t, and t is in the denominator. We use a quotient rule. So how do we use quotient rule? First we write this 1 minus b plus bt as I have shown you here. First we write this gx, okay, in the denominator, and then take the derivative of the numerator. And what is the derivative of numerator? And we are taking derivative with respect to t, and you can see here we have no small t here. That means it is constant here and its derivative will be 0, so I will write here 0, okay. Then we have minus this term, that is c naught minus b t naught plus I naught plus g naught, okay. So we write this fx as we have this term here and take derivative of this very term, okay. Here we can see we have only t in the last term. The derivative of t is 1, so we are left with only b, okay. So we have b here. I hope I am making myself clear, okay. How do we get this b? That means we need to differentiate d upon dt 1 minus b plus bt, this very term with respect to t. Since no t is involved, so derivative will be 0 here, derivative will be 0 here, the derivative of t is 1, so we are left with b into 1. That means we got b here, okay. I'm just trying to make sure you got the things correctly. Now we have 1 minus b plus bt, and it is squared by the formula of the quotient rule of differentiation, okay. Now anything multiplied by 1 is 0, and we have here b. If we take it on here, so we are left with minus b c naught minus b t naught plus I naught plus g naught, okay, upon 1 minus b plus b t square, or we are left with minus b 1 minus b plus b t square, and we have c naught minus b t naught plus I naught plus g naught here, okay. So what does this tell us? It also tells us there is a negative relationship because of this very term. That means 1 unit increase in tax rate, okay, that is small tax, small t, sorry, small t, will lead to fall in equilibrium level of income by the tax rate multiplier, okay, tax rate multiplier, okay. I forgot to rearrange this, so I will write it here, so sorry for that. So let me rub this out. uh, this dy upon dt, that is dy upon dt, is equal to what it is minus b upon 1 minus b plus bt square into c naught plus b t naught plus I naught plus g naught. We can rearrange this again. I can write it like this: minus b 1 minus b plus bt, okay, into this c naught, uh, actually it is minus b, minus here, okay, we have minus b t naught plus I naught plus g naught, and I can write it here 1 minus b plus bt, okay, because if we multiply these two it will get square root again, or dy upon dt is equal to minus b upon 1 minus b plus bt, okay. And this term you can easily see this is equal to this term which we have earlier calculated for the equilibrium level of income, okay. Then in place of this I can write y, that means dy upon dt is equal to minus by upon 1 minus b plus bt, okay. This is our tax rate multiplier, and you can easily see it is less than 0 because of this negative sign. And what does it tell? It simply tells a 1 unit increase in the tax rate will cause national income or equilibrium level of income to fall by an amount equal to the tax rate multiplier, okay. I hope I make myself clear. So here I forgot to insert this very equation, so I wrote it here to make it more comprehensive. I hope I make myself clear in this video. If you like these videos, please share, subscribe. That's only motivation for me. Keep going on. Thank you.